Thanks, everyone. We are here today for the seventh session of the Multispecies Studio. I can see that there's a steady decline in number of participants. Not surprising. Happens all the time with online courses for sure. But for those of you who are here, thanks for joining. So this week's session is on cognition. And I want to give you a very brief overview of something that is quite an actively researched field. And of course, I'm going to be presenting it from a point of view that may not be standard for someone who knows cognitive science somewhat well. But the first question that arises is, what role does cognition play in a multi-species approach to a city in the first place? And the most important thing for us to recognize is multi-species approach, as opposed to say standard ecology as an alternative, all the species who are in the multi-species city are subjects, right? Which is to say that they have a point of view on the world, they have interests, they're beings like us, right? So it's not just their behavior that we are interested in, we are also interested in their minds, so to speak. And the study of the mind is what these days is called cognitive science. Psychology is not terribly far away from that. We can call this multi-species studio week 7 psychology, but in some ways the modern framing around cognitive science and cognition is a more theoretically and experimentally richer discipline. I'm going to start with very cognitive sciencey framing of the problem of consciousness. Why consciousness, first of all? Again, as I said, we want to incorporate non-human species as beings that experience the world, that have a point of view, that have a first-person perspective on what it's like to be a dog or a bat or even a cockroach in a city. And that is precisely what consciousness is about, right? Consciousness is what it's like to be an experiencing being, what it's like to see the world from your point of view. And there are three problems that have emerged in research. Actually, the first two are the only ones that have a label in the last 20, 30 years. The famous division between easy and hard is due to a philosopher named David Chalmers, who wrote a book on consciousness, I think came out in 1991 or 92. And Chalmers distinguished between the easy and the hard problem of consciousness. Let's say that you are looking at a red rose in front of you. Chalmers says that the easy problem of consciousness is to perhaps isolate the portions of your brain that are responsible for seeing the rose as red, right? So some kind of neural correlate of the consciousness that you're seeing. The hard problem, according to David Chalmers, is why is it that there's an experience in the first place? Because photons are impinging on your retina, those in turn, so the rods and cones transduce that and turn it into electrical signals in your optic nerve that goes into area V1, V2, and so on. There's nothing in those electrical impulses that corresponds to the first person experience of anything. So why is it that something that is physical, electric signals, chemical reactions, electromagnetic radiation, how is it that they turn into the experience of seeing a red rose? So that's the hard problem of consciousness. In the middle, and I think that's actually the most valuable in my view for our work, is what I call the medium problem of consciousness, which basically says, why is it that you experience the world this way? And let me go back to that red rose example, which is when you see a red rose, why is it that the red rose appears in the particular way that it does, right? So imagine that when you see a red rose, instead of experiencing a red rose, you experienced an image of a red rose. that would still give you an approximate clue of what it's there in front of you. It would still be a first person experience, but it would be a totally different kind of first person experience, right? So, why is it that the precise way in which you experience the world is the way that you experience the world? And in some sense, that has been the problem of psychology, at least some strands of psychology and cognitive science from the beginning, right? Which is that we live in a 3D world with shapes and surfaces and sounds. And the precise character of our experience is what we want to probe using scientific techniques. Okay. So I'm going to focus on the medium problem. Why does the world look or feel the way um, it does? And the reason that's important for a multi-species thing is that we want to know what it's actually like for a dog to experience the world, right? What is it like for the dog to see the world? And is it possible for us to deeply see the world from the point of view of the dog, right? This is the problem that the two readings that were shared. Ed Yong's book on the immense world, very successful book recently written, is based on the much older work by Uxkul. Uxkul is, in a sense, the pioneer of the medium problem of consciousness, if you want to see it that way. But I'm going to start with an approach to the study of perception in our now terminology of study of consciousness, which is called the Gestalt approach to perception, right? What did the Gestaltists do? You might have seen or heard the word Gestalt in many circumstances. The most common version is the saying, the whole is greater than the sum of its parts. But in the late 19th century, early 20th century, uh, field of psychology arose, started by a psychologist in Germany called Max Wertheimer, which is the Gestalt approach to perception. And the Gestaltists were trying to understand why is it that we see the world in terms of wholes? Like why we see the world in terms of shapes and figures and layouts. We don't see it as images, we don't see it as total chaos. So there is some kind of ordering to our perception, which we just take for granted. But the Gestaltists said, let's try to figure out how is it that the world is ordered the way it is, right? And the fundamental principle that the Gestaltists keep using is the law of pragnanz, right? Which says that we tend to order our experience in a manner that is regular, orderly, symmetric, and simple. The Gestaltists very much took what we may say is a sort of a physicsy approach to the mind, right? That there are some principles, symmetry principles, ordering principles, which are the Gestalt laws that organize our sensation and turn it into the perception that we perceive. Okay. And an example of that, if you see that panda on the right hand side of the screen, um, it's a 2D image. In fact, it's just a 2D pattern of black and white, but all of us automatically organize it into shape that is recognizable as a panda, right? Or the bird and the sun in the middle. So these kind of standard, right? And the kind of, so what the Gestaltists did is they said, let's come up with these rules of perception, right? The Gestalt laws. So what are some of the laws? Um, Law of closure, that the mind may experience elements it does not perceive through sensation. So if you, again, let's see, if maybe you'll see my cursor, I hope you do. So if you take a look at right here, right, this white actually is not, it doesn't really exist in the image. This white patch is actually continuous with the rest of the PowerPoint background. And yet you clearly see it as part of the panda and not part of the background. So how do we do that? Then there's the law of similarity, that the mind groups similar elements into collective entities or totalities. So again, if you take a look at the second, so you have all these triangles, right? So these are similar elements and they are grouped together and but notice they're not grouped together with the elements in the bird, right? So the same three triangles, which are on the bottom, are part of the bird, while in the top are part of the sun. And so uh, we're making assessments of what is similar to what. Law of proximity, which says the spatial or temporal proximity of elements may induce the mind to perceive a collective or totality. So things that are close to each other belong to the same thing. Again, these three triangles are close to each other, they belong to the same thing. Those triangles are close to each other. But the deep question, of course, is how do you create the boundary, right? How do you know that this triangle and this triangle are actually not part of the same thing? Okay, so that's one of the questions that we need to answer. Then there's the law of symmetry, that symmetrical images are perceived collectively, even in spite of distance. The idea being that something that is symmetric is likely to belong to the same object, whether it is far away or close by, right? And then there's the law of continuity, that the mind continues visual, auditory, and kinetic patterns. And you can see that here, that the H, like the cross in the H, continues on to the maple leaf. And therefore, the maple leaf is actually part of the letter as opposed to being a separate object, right? And elements with the same moving direction are perceived as a collective or unit. Unfortunately, I don't have a video to show, but you can Google law of common fate and you'll get to a lot of YouTube videos on this. What Uxkul says is that this sort of is the Gestalt take on Uxkul, is that our perception comes together as a world. It doesn't come together as random sensations. It doesn't come together as chaotic patterns. It comes together as a world that we inhabit. And Uxkul would say that is true of a tick or a deer as much as it is for a human being. So we are all sort of inhabitants of worlds. It's the very nature, perhaps, of being alive. And what the Gestaltists are bringing to this table is what exactly organizes the world, right? So these are the laws that organize our world as a coherent, complete whole. So why are they so important for multi-species studies? Why should we think about other species as belonging to worlds rather than just being standalone objects that behave? So I'm going to go through some of the sections from Uxkul just to explain this point. So Uxkul starts by saying the present booklet does not claim to serve as the introduction to a new science. Rather, it only contains what one might call the description of a walk into unknown worlds. These worlds are not only unknown, they are also invisible. Furthermore, the justification for their existence is denied by many zoologists and physiologists. So, what Uxkul is trying to say is that if all animals have their own worlds, then if you look at an animal and you see it as an object in your world, you're actually missing out on the fact that it also has a world that it inhabits. And perhaps its world is not the same as yours. That is really clear for a tick, but it is likely the case for a dog as well, right? And the reason why these worlds are invisible is that what is visible to you is because of the very nature of perception. It is your world, right? You inhabit your world, you assume that is all there is. But of course, if you have a world, so does a tick and so does a deer. And we should assume that they are also walking around in their own worlds in the way that we are, right? As opposed to just assimilating them to our world. So, what Uxkul therefore says, whoever is not yet an adherent of the machine theory of living beings might, however, consider the following. All our utensils and machines are no more than aids for human beings. Of course, there are aids to producing effects, which one might call tools. So, a hammer is an example of an aid for producing an effect, for hammering things. And a class to which all large machines belong, such as those in our factories that process natural products and furthermore all trains, automobiles, and aircraft. But there are also aids to perception, which one might call perception tools. And he says telescopes, eyeglasses, microphones, radio devices, and so on. And one kind of account, and we have, as it so turns out, a much more sophisticated idea of what a machine is than what Uxkul was talking about. But Uxkul's basic point is if you reduce our capacity to act on the world and our capacity to sense the world to certain kind of technological analogies, that our senses are like telescopes and microphones, and our hands and feet are like hammers and great or robotic legs, then all we are is a machine, right? We are basically just a collection of mechanical parts. And Uskul says, definitely in modern physiology, in biology, the assumption has always been that perhaps besides human beings, every other animal is a machine. And so, what Huxley says, from this one can readily assume that an animal is nothing more than a selection of suitable effect tools and perception tools. So, we are just sophisticated assemblages of, and I'm using the word assemblage very explicitly, going back to the reading that we had in this second week, right? That we are nothing more than an assemblage of perception tools and effect tools, which are bound up into a whole by a control device, which, though it remains a machine, is nonetheless suitable for exercising the vital functions of an animal. This is, in fact, the view of all machine theorists, whether they are thinking of rigid mechanics or flexible dynamics. Animals are made thereby into pure objects. In so doing, one forgets that one has from the outset suppressed the principal factor, namely the subject who uses these aids, who affects and perceives with them. Uxkul is trying to stipulate that there is a subject who is more than just the assemblage of machine parts, both perception machines and action machines. This may feel a little bit like introducing the soul into the mechanical world. And that is why actually the concept of a world is super important, because the subject is not something that kind of is ethereal quantity that lies behind the body, right? For Uxkul and for anybody who thinks that way, it's only the subject and a subjective view of reality that actually also creates a world around the animal, right? Machines don't have worlds, at least not, there's no reason why a machine should inhabit a world, but an organism does. And there's something more, but the more is not inside, it's as much outside, right? What has changed between the time that Uxkul wrote his book and today's work on consciousness is, of course, the idea that the mind is a computer, right? So, in particular, the most sophisticated idea of a machine that we have today is that of a computer. And there is a possibility, therefore, that computation brings together the mechanical way of looking at the world and the subjective way of looking at the world that Uxkul cares about. That, by the way, that doesn't exist. It would be, it's a research program that needs to happen. Right? How does computation take build upon what the Gestaltists and others researched through the various laws that we saw a few slides ago? So the geometric theory of perception is perhaps the easiest way to explain this. If you think about it, and you form an image in a box, if you have a pinhole camera, so this is an example of a pinhole camera, you can see that the image is formed in an inverted fashion. But of course, we don't see an inverted tree, we see an actual tree. So therefore, the question is, how is it that images are formed, and how do we turn an image into the actual perception that we perceive? So this is the basic task of the geometric theory of perception. And the most famous and major kind of research advance that was done was by David Marr and his collaborators at MIT, where he systematically brought computation to bear on perception, right? So Marr starts his book called Vision by saying, what does it mean to see? The plain man's answer, and Aristotle's too, would be to know what is where by looking. The claim is that seeing is how you access the world outside, both in what it is that you're seeing and where it is that that object is relative to you. And the way he brings in computation or information into the picture is vision is therefore, first and foremost, an information processing task. But we cannot think of it just as a process. For we are capable of knowing, for if, so the if should be underlined, for if we are capable of knowing what is where in the world, our brains must somehow be capable of representing this information in all its profusion of color and form, beauty, motion, and detail. And so the key word there is representing, and I want to go back to the previous slide. So in some ways, what the pinhole camera has done is it has represented the 3D tree in the form of a 2D image, but which is inverted, right? But according to Marr, what we need to be able to do and to explain is to see how the brain takes that inverted 2D image, but turns it into a representation that actually has color and form. So form in particular here is 3D, beauty, motion, and detail, right? So somehow we should be able to represent the world as the tree as a tree in its various forms of tree as a 3D object of great size and beauty that's in front of you, rather than just as a collection of 2D images. Okay. So the general scheme for a computational way of looking at the mind is you start with sensations, a retinal simulation, and this 2D image is the starting point, right? And then you do all kinds of additional processing that can be done through some form of, to use today's machine learning language, it's some form of inference, and produce the 3D object, right? So what David Marr does is by saying, we start with a 2D image, you detect all kinds of boundaries and edges in it, turn it into what he calls a 2.5D representation, which is surfaces. So you can see that there is an illusory contour here. You can probably see it as two triangles, a white triangle in front of a black triangle. So that's an example of a 3D perception that emerges, or rather 2.5D perception that emerges from a 2D image, right? And finally, we of course parse it in terms of objects, which is of course these two objects, the two triangles in front of, and the white triangle not only being on top of the black triangle, but also being on top of three black spheres, three circles. Okay. And the big computational challenge is that vision is severely underdetermined. And a good example of that is the Necker cube. So you can probably see this in two forms. Either this vertex looks like it's in front, but it can switch and become a skew with this vertex in front, right? And so what Marr and others successfully pointed out is that vision is severely underdetermined by the stimulus. So your brain needs to do a lot of processing to extract the actual 3D shape of the world, right? And this is broadly how the computational theory of mind has worked for the last 40, 50 years. Now, of course, we have much more powerful statistical techniques, but conceptually, it's still the same. Gibson, whom we have met in the last 2 weeks ago, dissents from this approach. He says actually that it's not like you need tons of processing in your brain. He says that I argue that the seeing of an environment by an observer existing in that environment is direct in that it's not mediated by visual sensations or sense data. The phenomenal visual world of surfaces, objects, and the ground under one's feet is quite different from the phenomenal visual field of color patches. I assert that the latter experience, the array of visual sensations, is not entailed in the former. Direct perception is not based on the having of sensations. The suggestion will be that it is based on the pickup of information. Of course, not clear what pickup means and what information means. But the theory here advanced assumes the existence of stable, unbounded, and permanent stimulus information in the ambient optic array. So, if you want to go back to Uxkull, what Gibson would say is that the world of the animal already has all the information that the animal needs. It doesn't need to represent that information. Instead, it supposes that the visual system can explore and detect this information. So, an example of that is optic flow. This is a plane landing on a runway. And if you take a look at it, this spot, oops, sorry. So where my cursor is, that point in the middle is the heading direction. And what Gibson would say is that the stimulus array, which is your retinal simulation, already tells you where the heading direction is because it's the point which doesn't, where the vector of flow of the image doesn't move. Every other point has some kind of image motion, but not this point right at the center. So it's the place where it's the location in the image where there is no motion. And so what Gibson would say is that gives you a direct clue as to where you're going. You don't need to take the image, process it, and then find out. And this is a topic of a great deal debate, but for our purposes, we can come back to Uxkull. If we combine Uxkull and Gibson, we get this idea that the world of the animal has a lot of information. Okay. Uxkull doesn't use the language of information or computation, but if we combine the two, we can think of the worlds of ticks and deers and dogs and humans as containing species-specific information. What does Uxkull say? He says, whoever still holds the view that our sensory organs serve perception and our motor organs serve the production of effects will also not see in animals simply a mechanical assemblage. They'll also discover the machine operator who is built into the organs just as we are into our body. But then he will address himself to animals not merely as objects, but also as subjects, whose essential activities consist in perception and prediction of effects. So it's this subject, and the subject is very important not just for this purely scientific or natural scientific exploration. We also use the word subject in a related but different way for social science purposes. We say somebody is a political subject, that I am a subject of the government of India. If that's the case, then there's a way in which you as a subject belong to a political community, and it's precisely the connection between that political subject and the cognitive subject that Uxkull is talking about here that becomes crucial when we are looking at multi-species cities. Okay, so we begin such a stroll on a sunny day before a flowering meadow in which insects buzz and butterflies flower, and we make a bubble around each of the animals living in the meadow. So this is Uxkull's theoretical or conceptual innovation right here, which is to think of each animal as moving around in its own world. That bubble represents each animal's environment and contains all the features accessible to the subject. As soon as we enter into one such bubble, the previous surroundings of the subject are completely reconfigured. Many qualities of the colorful meadow vanish completely. So what Uxkull is trying to urge us is to take a novelist or perhaps a mystic's empathy that allows us to enter into the world of another subject. And he thinks that is possible, by the way, otherwise he won't be doing this. So the blind, so now he's talking about ticks, right? And he has this really evocative description of what a tick does. He got the blind and deaf bandit, right? It's not able to or hear. It actually, its world is a world of smell, followed by a world of touch. He says the blind and deaf bandit becomes aware of the approach of its prey through the sense of smell. The odor of butyric acid, which is given off by the skin glands of all mammals, gives the tick the signal to leave its watchpost and leap off. So it's waiting, and it can be waiting for enormously long periods of time. But once an animal shows up, and it smells. That smell actually triggers awakening. It makes the tick turn on, so to speak. And then if after the tick leaps, if it falls onto something warm, which its fine sense of temperature will tell it. So it's got a temperature sensor and a chemical odor sensor. Then it has reached its prey, the warm-blooded animal, and needs only use its sense of touch to find a spot as free of hair as possible in order to bore parts past its own head into the skin tissue of the prey, right? And then the tick pumps a stream of warm blood into itself. So besides the fact that there are three sensory modalities, so smell followed by temperature followed by touch, and another important thing that Uxkul is pointing to is that the senses are temporally ordered. There is an actual sequence through which the tick organizes its sensing of the world. So it's not just a static 2D image, but actually their senses are deployed in a specific order. Then the poor thing lays his eggs and dies, right? What Uxkul is trying to do by empathizing with the tick, right? We look at how he describes it. He says the tick's hearty blood meal is also its last meal. So it's very much written in a kind of tragic prose. Uh, he's describing the tick also as a being whose life has meaning. Now, whether that meaning is similar to the kind of meaning that we have or we give to our lives, or is something totally different, is of course a matter of debate and discussion. Uxkul is not Darwinian, but we may actually want to ask, if you want to bring Darwinian theory into this, what kind of evolutionary purpose does this meaning making have? Um, that's a question for us to ask, right? But all of this is really going back to the what it's like to be a bat question that was posed just before we started the seminar, the first reading by Nagel. So what Uxkul is doing is he's actually saying this is what it's like to be a tick. He's entering into the world of a tick, and he's saying that even as alien an organism as a tick has a world that we can enter. So in that sense, he strongly differs from Nagel, who thinks that we have no way of knowing what it's like to be a bat. Okay. And this is why it should matter to us. It matters to us because if we want to create multi-species cities, we want to know what it's like to be a dog or a sparrow, even a cockroach. And it should matter to us because if indeed it's possible for us to see the world from those perspectives, then we might be able to design living environments that are multi-species environments, right? And that's where, if we go back to Uxkul again, up here, sorry, that if we make a bubble around each one of those, what time is it? Oh, I'm almost done. If we create a bubble around each of the animals and we see those bubbles as what we should be designing for, right? Just as we inhabit cities with similar bubbles that are walking around, and human-centered design helps us create artifacts that work for humans, maybe we can design for the bubbles around other species as well. So that's the final twist to the tale. So we started by looking at the bubbles around each animal. So from Uxkul, we basically got the idea that there is a bubble. From Marr and Gibson, we got the idea that the bubble can be understood through the language of information. And then finally, we might want to add a layer of design that says, if we have that information, we can design for artifacts that makes the lives of humans as well as other species better. So that's broadly the arc of the story. And with that, I'm going to end at least the lecture portion. Sartaj, I don't know if you have any questions, anything that we want to, but also stop
Yeah.
sharing.
Yes. Thank you. That was a really nice lecture. So, a couple of questions. The first one is that you started with the medium problem of why the world looks or feels the way it does.
Mhm.
And I feel like you just touched upon it really lightly. And do
Mhm.
you want to talk a little bit about that more?
Yeah. So in some ways, I should have been more explicit. The Gestaltists pose that problem most precisely, right? The Gestaltists are saying that we don't see the world in terms of random sensations. We see it in terms of continuous perceptions, and the continuity is both in space and in time. So our perceptions cohere together as objects. So that's a spatial kind of coherence. And they cohere together as events that are in some causal relationship to one another, right? So not unrelated events, but related events. So the medium problem of consciousness, in some sense, is to say, why is it that the world is ordered that way, right? The Gestaltists made a huge advance in by being precise about how they described the ordering of that world. They gave us some clues as to the spatial and temporal ordering. Computation might perhaps give us ideas on exactly how that happens. That's
But
the, yeah.
just a different take on it. Like,
Mm.
I remember reading about and also discussing with you at some point about questions like why sugar is sweet,
Yes.
and coming at it from an ecological
Mhm.
point of view. I remember also there's why jokes are funny, right? There's research on why jokes are funny. But if you were to answer like why sugar is sweet from an ecological perspective, it
Mhm.
would be that we are designed to like things that are nutritious, and sugar is concentrated nutrition, and so we find it really sweet. And I think
So
that
the
is
there's a complication here, and I'm glad I know that we have had this conversation a long time ago on why is the sweetness of sugar a particularly important example of this medium problem. So the hard problem of consciousness would be, why does sugar taste like anything at all? But the medium one says, why is it sweet? So, for example, there could be many pleasurable sensations, but sweetness is a very particular one, right? I find other citric or other tastes also pleasurable. And so, why is it that sugar is that specific sweetness and not something else? Seems to not have an answer, right? The kind of ecological argument or evolutionary argument that you're giving doesn't really tell me why it is this pleasurable sensation rather than that one.
But I think on the gradient, you're pushing it towards the harder side of the problem. But
Yes,
if you were to bring it back into the medium range, you could use this as a way of getting into the worlds of other animals.
sure.
Because if we're all evolutionarily related,
Mhm.
it would give you an insight into why animals are attracted or how they're attracted to things that are nutritious, right?
Sure, sure,
And could give you like a sense right down to unicellular organisms which
right.
have to find things that are nutritious.
So if we go instead of sugar, which is such a refined
Yeah.
product, so it give
Concentrated. Yeah.
yeah. But if you take a look at so if you most things except for honey, it's rare for us to find concentrated sugar in the wild. But if you take an apple, the apple gives us lots of clues that are broadly similar, right? Visually, it appears attractive. at least to me, right? But and the redness, what I'm saying is that I experience the visual redness of an apple, not just as aesthetically attractive, but also somehow tasty, right? Like there is a kind of visual clue as to its taste, but that's not the same as sweetness, right? So what's interesting is how the different, again, if you go back to that Uxquillian successive deployment of senses, there seems to be an order in which vision goes to taste, goes to smell, goes to taste, even in this particular case, I think. And I
Yeah,
feel like
so I
those are
will
some of the medium kind of things that are worth discussing.
so I will respond to that, but I'll also mention that people can now ask questions. So if anybody has a question, you can raise your hand or put
Uh-huh.
it in the comments or any of those.
Mhm.
But what I was going to say is, so we can also use this framing, this ecological framing, to arrive at an ecological aesthetic.
Mhm. Yeah,
So we know that apples are good for us, right? And trees are good for us. Like a place that has a lot of trees is a good place for a human being to be.
of course.
And yet, through a lot of different processes, one of which is hijacking of our senses, we've lost sense of what we ought to find beautiful.
Yeah, yeah.
And to a lot of people today, a well-stocked supermarket shelf is much more attractive than a tree with apples on it.
Really? I'm not so sure. Really, if
Yeah,
that
yeah.
is true, then
I know this because I was teaching class ninth an English poem the other day, and
uh,
the poet mentioned a list of beautiful things, and he mentioned trees,
uh,
and everybody was stumped because they had never thought of a tree as beautiful before. And I was
what?
shocked when I heard that.
Oh,
But
that's really depressing.
yeah, and insightful.
Okay. That if that is actually true, I'm wondering if there's a way to test that. I'm wondering if people are substituting their ideas of prosperity and whatnot of modernity and so on, but that actually if you put somebody in front of a apple tree versus a supermarket shelf, what will they find more? I really hope it's not the case that the supermarket
I'm
shelf is
I'm I'm pretty sure. I think I'm like
okay.
pretty sure about which way people are gonna go.
But
And I
then I
think it's
mean,
big.
okay, sorry, I didn't mean to interrupt you.
It's the same. I think it's the same reason why. So our taste buds that were designed for us to like wheat or rice or carbohydrates and then got hijacked by sugar. I
Right.
think all our senses are just hijacked. Like Instagram is basically like the back end of it is how to
Mm.
hijack the human
Oh,
mind.
of course. And of
So
course, attractive people being in attractive places is Instagram's dopamine.
I mean, like I would say, like babies like being walked because the changing visual scenery is good for
Yes.
them. But
Yeah.
a TV does that for them while they're sitting, and
Right.
so it hijacks that sense.
I know, Sataj, you've been pushing this in other conversations too, that maybe what we need is a kind of ecological outreach that's also a sensory outreach, right? So it's not, so meaning it's not just, oh, here is this kind of insect and that kind of tree, but also actually learn to see the tree and the insect, right? And to,
Yeah,
yeah, yeah, important point. I don't see any questions being raised, at least so far.
yeah.
So maybe, Anshuman, if you don't have a question, we have, I think, enough people that we can move to the next.
Yeah, yes. So Anshuman has put the documents, Google Doc links in the chat. We can split up into the same groups as last time because there are, I think, a lot of people who were there last time as well. Anybody who is new can join any doc at random. So this week's exercise, as I had imagined the city from three different perspectives, from the perspective of a dog, from the perspective of a sparrow, and that of an insect of your choice. It could be a spider, it could be a butterfly, it could be any insect. So how would the city look from the perspective of a dog, a sparrow, and an insect? You can just write like small paragraphs about this in the document, and it can go as an addendum to your design of Shaktivel. So we can take about 25 minutes to do the exercise now. I will put the prompt in the chat as well. Anything you want to add, Rajesh?
No. Yeah, just to build upon the content of today's lecture, just imagine each one of these entities as an actual being, right, with that bubble around their heads, and try to describe what it's like when you enter the bubble. Yeah, yeah. I don't know if we can go yet into what it's like to be an AI, Rajit. It's hard, yeah, but obviously, given how interested we are in AI these days, it's an obvious question, right? And in some sense, is it also just as the question arises, can AI be conscious? I think the question also arises, can AI have a world? Yeah.